Okay, this is going to be our video for section 4.3, and this is where we are going to take our chemical reactions that we would have a balanced equation for and draw some representations. So we're going to start off with a basic one here, CH4O2, those are reactants, and they are forming CO2, and H2O are products. So the balanced equation that we have, CH4, 2O2 yields CO2 and 2 H2O. So for every one methane, we're going to have 2 oxygen, and that combination will give us 1 CO2 and 2 H2Os. Okay, so our equation is balanced, as is our particulate diagram. So let's look at one that is a little bit more complicated here, but not really. So just like the last time, we have our reactants, we have our products, we have different products from our reactants. So that's how we know that a chemical reaction is happening. Bonds are being broken here, and then new bonds are being formed. So we have H2, which are these white diatomic molecules, and O2, which are these red diatomic molecules. So in order for this reaction to happen, we need to be able to form bonds between the oxygen and the hydrogen. But before that can happen, the bond in between the hydrogen in each of these molecules and the bonds between the oxygens in each of these molecules must break in order for the new ones to form between the hydrogens and the oxygen to make water. Okay. So in this box, we're starting off with 10 H2 and 7 O2. And then over here, we are getting our new species of H2O. So we are getting 10 H2O. And we have a little bit of leftover oxygen, which is interesting. So this is actually demonstrating a concept known as limiting reactants. And that is going to be really important for us in a few sections. So keep this in the back of your mind, that you're at least being introduced to it now. So over here, we have 10 H2s and then 7 O2s. Well, we're using up all of the H2 so that we have none left, but we have some leftover oxygen. So that means that we had excess oxygen, and our H2, or the hydrogen, was the limiting factor. So we could only form 10 water through this reaction because we only had 10 hydrogens. If we had more hydrogens, then we have the potential to form more since we have leftover oxygen, okay? But since we are going and we are using up all of the hydrogen here and we have none left over here, that tells us that it is our limiting reactant, and it is therefore limiting the amount of water that is forming in the reaction. Okay. I would like you to, for the next 3 practice problems, I think there are, once I read the question, I want you to try this out on your own. So for the purposes of this, I will have the answer for this first one, but then I will provide you with a video later today that has the answers for the other ones. Okay, so we have ammonia gas at 1000 degrees Celsius. It will react with oxygen gas. These are our 2 reactants, ammonia and oxygen. They are reacting together to give us nitric oxide, and water vapor are 2 products. So we need to write out a balanced equation using what we know about our reactants and our products. We need to balance it, and then I want you to draw a particulate representation, either in the form like we have here or the form like we have here. Okay, so you can choose whichever one you want to do. All right, so pause the video now, and I will give you a few minutes to do that. And then when you're done, unpause and we will continue. Okay, so let's take a look at what the particulate representation would look like here. So we have our ammonia, NH3, oxygen, NO, the nitric oxide, and the water. So this is balanced right here. So we have 4 NH3 for every 5 oxygen, and they will combine together to give us 4 NO2, or I'm sorry, 4 NO, and then 6 H2O. So hopefully whenever you balance the equation, that is what you got, and then your particulate representation looks like this. For the next problem, you have calcium hydroxide, and it is combining with phosphoric acid and a calcium phosphate precipitate occurs, and then liquid water is also produced. So we've got our reactants. These are both going to be aqueous since they are in solution. The calcium phosphate, if it is a precipitate, tells us that it must be solid, and then we just are given that it is liquid water. Okay, so you have your reactants, you have your products. So go ahead and write out a balanced chemical equation, and then draw some particulate diagrams. Onward to practice number 3. So now we got silver nitrate and sulfuric acid. They're both solutions. They are combined, and we will get a silver sulfate that precipitates. So go ahead and write out a balanced equation. If you want to get real fancy, you can also write out the net ionic equation, okay, for our silver sulfate. But go ahead and write out the balanced equation and then draw a particulate diagram for that. Okay, so this is our equation. But like I said, I will provide you with that particulate diagram later. Okay, so for homework, or I guess with whatever time you have now, I would like you to write out the balanced equation and particulate diagram for these reactions. So the absorption of carbon dioxide by solid lithium hydroxide, so that will produce solid lithium carbonate and liquid water. So use what you know about ions to determine what the chemical formula will be for each of these species. And then also the combustion of propane, which will be important here and as we move forward. And that is all for today.